Good morning to everyone and welcome to today's webcast. The purpose behind the webcast is to give you short, informative sessions on topics. We don't generally tend to dive into huge technical detail. This is more of an overview session. If you do want to discuss certain aspects in more detail, then please contact me and you can do this then on a one-to-one basis, either virtually or face-to-face. My name's Emma Ryde and I'm one of the product managers here at Rittal. As you can see, I'm part of a large team of product managers in the UK, and we are here to support you technically with any questions or applications or projects that you may have. I will put my contact details at the end of the webcast should you need them. Also throughout the session, if you do have any questions, then please put them in the chat function. And what I'll do is I'll endeavour to answer these at the end. That way, then it doesn't disrupt the flow of the session. If for any reason I can't answer your question today, or sometimes I do come in slightly after the webcast is finished, then I'll have your details so I can come back to you individually. The session will last approximately 30 minutes, but the webcast will be recorded so that if you feel that you've missed anything or some of the information may be of use to a colleague, then you can watch it back later. And it will also be uploaded to the Rittal Limited UK YouTube channel later in the week, and it will also be available on our website. So let's get started. So I want to take you through some of the considerations if you need to place an enclosure outdoors. But I want today's session to be more educational than product focused. Obviously, I will be showing Rittal product because that's where I've gained the experience and knowledge from, but the principles are the same. So lots of people make the mistake of looking at the wrong types of features of an enclosure for its suitability outdoors and then ultimately ends up failing. This then leads to the assumption that the enclosure is of poor quality, when in actual fact, it simply wasn't designed for that purpose. So I'm hoping by the end of the webcast, it will give you some food for thought for if you have to place an enclosure outdoors and that you potentially look at factors you might not have considered previously. Unfortunately, many enclosures are also selected on cost, and I always find this quite worrying when in a lot of cases, that enclosure is there to protect the critical infrastructure, and it can be housing equipment in excess of tens of thousands of pounds, not to mention the subsequent costs associated if that internal equipment fails. We can see here the topics for discussion and hopefully dispel some of the myths surrounding these topics today. When it comes to materials, stainless steel is regularly favoured, but there are other materials out there that can outperform stainless in the right environment. IP ratings as well is something we're going to discuss. It's always a great discussion point. We're often asked to supply enclosures to IP ratings that simply don't fit with the application. So again, hopefully this will help you to understand that although IP rating is an important feature, there's other considerations as well when it comes to outdoor. Climate control, this is continuously overlooked when it comes to outdoor applications. So again, today we'll address that. But for me, the biggest topic to look at is the actual specific design of an outdoor enclosure. So there are several materials that are favoured when placing enclosures outdoors, but how do we decide which one is right one for the application? So materials such as stainless steel, aluminium and GRP are the most common, but each material brings with it its own characteristics as well as factors that need to be considered. So if we look at stainless steel, for instance, there's many different grades of stainless steel, but most commonly used is grade 304 and 316. 304 tends to be the more cost-effective option. However, in the wrong environment for long enough, it will corrode. For applications whereby salt water is present, the 316 grade of stainless is more favourable because obviously this offers a higher degree of protection. However, while stainless can look like a good fit, what we do need to do is weigh up the other factors as well. Things such as, are there other materials that will perform just as well in your application? Like I said, stainless will rust in certain environments, and whilst cost shouldn't be a concern, it's certainly worthwhile considering if other materials perform just as well, and they also have other benefits that might be cost effective as well. If we look at another metal option for enclosures outdoors, then for me, aluminium is certainly the strongest contender. Whilst untreated aluminium can be affected by corrosion, if it's exposed long enough to water or chemicals, due to how aluminium reacts with oxygen, what it does is it forms a thin coat of aluminium oxide that then chemically bonds itself to the surface of the metal. Now you can usually tell if this has occurred as it appears as a dull white finish on the surface. Now, this oxidisation doesn't flake like rust does, and therefore it will stay intact until it's removed. Therefore, really, its reactive nature can actually be seen as a good asset to the material. Now, if we look at using aluminium outdoor enclosures, you'll find them also powder coated like the ones in the images above. Now, this then powder coating offers yet another layer of protection, which will then increase the lifetime of the material. So you have the powder coated layer on the enclosure. If for any reason the enclosure is damaged unknowingly and the paint is removed or broken, then the aluminium underneath eventually will have an oxidised layer again, protecting the material unless it's removed. One argument against using aluminium maybe is that it isn't as strong as stainless steel. As a general rule, aluminium has a much better strength to weight ratio. And if we look at impact ratings, stainless steel enclosures offer an IK8 impact rating, whereas aluminium will offer an IK9. And the reason for this is because aluminium tends to bend, whereas stainless steel will crack. Overall, aluminium versus stainless offers good longevity of life, even with potential corrosion. It's more lightweight than stainless. It has good impact strength, and due to the strength to weight ratio, it means it's more cost effective. So for me, aluminium is a great option for outdoor use. So the last material I want to look at is GRP. So due to material constitution, when we don't have the same issues with GRP like we would do potentially with steel, therefore it makes an excellent choice for applications in harsh environments such as petrochem or marine. GRP can break down under UV radiation. What happens is the outer layers and eventually get like a powdery finish. Now, some GRP will have a coated outer layer, or it may have a constitution that gives it a higher UV radiation rating. But it's worthwhile checking with the manufacturer if you're looking at a GRP enclosure, if it has any recognised outdoor approvals or certificates for the UV resistance. Some manufacturers will state this in their marketing materials, that it has a specific UV outdoor rating. Now, while GRP is certainly a good contender for outdoor solutions, it can mean that you are limited to some extent on the internal fit out. Unlike steel, whereby the enclosure can either have internal fixings welded in, or the enclosure may have an internal frame that components can be attached to, GRP doesn't offer that type of functionality. Therefore, again, it's worthwhile considering if you're looking at this type of enclosure, can you achieve the internal layout you want now, or if you need to change anything in the future. GRP, again, though, it's lightweight in comparison to steel, and it's also cost effective. But as I mentioned earlier, the design of the enclosure is equally important. I'm going to discuss this a little bit more shortly. A really big topic to me that's generally misunderstood is IP ratings. We often see people requesting higher IP ratings, assuming this will mean it will work better outdoors, and this isn't the case. Whilst IP ratings are extremely important, it's also the specific outdoor design features of the enclosure that play a huge part in its performance, and we're going to discuss that in the next few slides. For example, most inland applications, IP55 is sufficient. This means the enclosure is protected against dust and jets of water. I've had many instances where people ask for IP66. Now, this for me is overkill for the majority of projects. By asking for a higher IP rating is necessary, what happens then is the choice of enclosures will be limited and could be considerably more expensive. If we look at the first digit, so IP6 for dust means it's completely dust tight. Unfortunately, enclosures tend to be accessed, whether this be for maintenance perspective or commissioning, for instance, then the enclosure door is open. At this point, dust has already entered the enclosure. If you've got equipment that's so sensitive to dust, then it's probably better to have an enclosure within an equipment building so that it's protected from the outer environment. If we look at the second digit, IP6 for water means protection against powerful jets of water. Now, in a marine application, this may be required, or we find this in food factories where enclosures are being cleaned for hygiene reasons. But for standard applications, then IP55 is the correct level of protection, along with the design features, which we're then going to discuss. Climate control. Now, this topic is overlooked generally, not just in outdoor solutions. The assumptions are that in the UK, the weather doesn't get too hot and the winters don't get as cold. Obviously, this year we've reached 40 degrees in the summer, but in recent years we're regularly seeing over 30 degrees throughout the summer months. So we have electrical equipment that generates heat sat in an enclosure. Yes, there will be some heat transfer through the walls, but not enough to counterattack that equipment that generates that significant heat. Items such as power packs, batteries, transformers, drives are all pieces of equipment that create significant heat loss. And if you have any of these, then I'd recommend you speak to us to help you with a thermal calculation to establish if you need climate control. In today's technology, this equipment can work at considerably higher temperatures, so it might be that all we need is passive cooling, such as louvers in the enclosure, or active cooling, such as a fan and filter, like the one shown here that also has a special outdoor fitting. However, if the equipment is more sensitive to temperature, such as telecoms or IT equipment or UPSs, then they may need to work in a much lower temperature in order to work at their optimum. In these situations, then we may need to consider a cooling unit with a refrigerant circuit, like the one we can see here fitted to the door of the enclosure. Now, while we give most consideration to the summer months, the winter months can be just as harsh, and electrical equipment tends to have a minimum operating temperature as well as a maximum operating temperature. So again, it's worthwhile considering a thermostat, an hygrostat, and installing a heater to prevent freezing or condensation. Climate control, really, it's all about keeping the internal equipment running at its optimum temperature, so its lifespans as long as possible. Now that means cooling the enclosure in the warmer months and heating it in the winter months. It's literally as simple as that. And like I mentioned, if you do have an application where this is something you need to discuss, feel free to contact us. Thermal calculations for outdoor enclosures are calculated differently to that of standard enclosure settings, but obviously we will happily help you with the process. So we've talked about the fundamentals of enclosures. For me, what's really important is the design. When we look at traditional indoor enclosures, the environmental factors that need to be considered usually aren't as harsh, and therefore a standard design enclosure is sufficient. But what do I mean about specific outdoor design? So we can see here a cross section through a standard IP66 cabinet with no rain canopy or protection from the seal. As you've heard me say, this is an IP66 enclosure. This will reiterate the point that a high IP rating doesn't resolve some of the problems outdoor environments can bring. So if this enclosure is placed outdoors, then ultimately rainwater will gather in this area and it will be in direct contact with the door seal. Rainwater is full of contaminants and it will degrade the seals over time. This will then leave no IP rating of the enclosure. Water in this area also in the winter months will freeze. This can then expand and can cause the enclosure door to push away from the body of the housing. Again, it's allowing ingress. So this is where we have to look at enclosures that take these factors into consideration. If we look at a design that would be more suitable to outdoor, then we need to protect the seals with a roof canopy or a rain strip. On the image on the left, we can clearly see an overhanging roof that will protect the door seal from sitting rainwater. On the image on the right, we have a wall-mounted GRP cabinet. This cabinet has a rain strip both at the top and the bottom. This allows the enclosure to be turned through 180 degrees with the same level of protection. And we can see from this image, it has two seals, one below the rain strip to the enclosure door, and then another seal against the main body of the enclosure. Now, this labyrinth effect gives a high degree of protection. Both these types of rain protection mean the seals will work as they intended and keep the IP rating intact. Another discussion point for outdoor design is that metal enclosures can come in both single and double skinned, and there's a place for them both. Again, it's simply considerations to which is more suitable for the application that you currently have. If we look at a single skin enclosure, then we need to understand that it has its limitations. Now, single skinned doesn't mean it has the ability to regulate or UV solar gain as well as a double skinned enclosure. I know that might sound odd, but I'll explain why shortly. People tend to think that a double skinned enclosure won't help with any type of heat loss or heat gain, but like I mentioned, it does. So for single skin enclosures, the security aspect isn't as high, and therefore it might be easier for someone to gain access should they wish to damage or remove any internal equipment. Therefore, I'd look to use this in a place where it's not in the public domain, more of an application on private land. However, single skin steel enclosures are ideal whereby you require an internal configuration that can accommodate different fixings such as mounting plates, 19-inch systems, like I said, if it's on private land, or whereby it has equipment that isn't as temperature sensitive. Although climate control can still be added, you don't get the benefit of some of the internal regulation with heat like you would do with a double-skinned enclosure. And this enclosure is more cost effective as well due to the volume of raw materials. So if we're looking for something that's cost effective, the equipment isn't as affected by temperature, it's on private land and we need a multitude of different fixings inside, and the single skinned enclosure could be the right type of enclosure for your application. Now, double skinned enclosures offer a variety of options, and this is where specific outdoor design is at its highest. UV solar gain for an outdoor application is a major cause for concern, and one again that's quite often overlooked. Now, whilst the cabinet will retain heat from the equipment, it will also have to deal with the increase in temperature from the sun. So double skinned enclosures as opposed to single skin assist with the amount of solar gain that is absorbed into the main body of the enclosure. Having a double walled enclosure means that some of the heat will instantly be reflected. Any enclosure can offer that. A percentage of the heat will penetrate through the first layer and it will then dissipate between the walls and out through the vented roof of the enclosure, and a portion will enter into the main body of the enclosure. A double skin roof canopy design can also assist when the sun is at its highest, so not only does it protect it from the rain, but it also serves as a sun canopy. Passive and active cooling can be added to outdoor enclosures, but if we're able to limit some of the heat absorption from the sun, then this will mean we can use a less active cooling method. To enable a double skin design, then the enclosure needs to have an internal frame for the skins, or the cladding as we sometimes call it, to be able to fix to. We can see here the image on the left, the internal frame, and a cross section through the skins. And then in the image on the right, we can see the exploded view of the frame with the first set of cladding ready to be attached. We can then see the second layer being attached. The clever design with this is that all of the fixings are hidden, so that when the skins are attached, it makes it more difficult for anyone trying to gain access that isn't authorised. So it's been designed like that, so all of the pieces have to be put on and off in a particular order. So it's a little bit like a jigsaw puzzle, and again, it makes it extremely secure. However, from a maintenance perspective, having two skins means that should one become damaged, whether it be accidental or malicious, skins can simply be replaced rather than the whole enclosure having to be removed from site and replaced. So this in itself can save huge amounts of downtime. If you can imagine a critical infrastructure application such as signalling on the railways, if a single skinned enclosure was to be used and the main body of the enclosure was damaged to the point it's compromising its performance, then the whole unit would need to be taken away. The equipment transferred from one enclosure to another and then reinstalled. There's huge amounts of cost, huge amounts of downtime in that. A lot of that could be saved if we were to use a double skinned enclosure. What would happen is, if the outer skins are damaged, literally we could just order the outer skins. Those could be brought to site, those could be swapped over, the enclosure will still stay in its original position, and all we need to do is change the outer skins that when they're available. Again, that saves huge amounts of time and downtime to the railways if that's the application that we're looking at. So we've talked about how having a double skin attached to the enclosure frame means robustness. What it also means is extra protection from those wishing to gain unauthorised access. Unfortunately, when enclosures are placed in a public space, in some instances the internal equipment can be seen as highly valuable. Design features that make it more difficult to access the enclosure can be enough to deter unwanted attention. However, if someone persists, some double-skinned enclosures can carry what we call a resistance class rating. The enclosure we can see here meets RC2 standards, which is widely used. This means the enclosure can withstand someone trying to gain access with small hand tools for a period of time. And this time frame usually is sufficient to either deter the thief or for enough time for them to be disturbed. Now, when you're placing a cabinet outdoors, you also have to consider how you're going to attach it to the ground. Sometimes you might be replacing an existing system and a plinth is available that the enclosure can be screwed down to. In a new project, simply screwing it to the floor probably isn't an option. Now, the above plinth system is a great solution. It can also be removed, so it isn't a permanent structure. So a hole where the enclosure needs to be sitting is dug. The piece of the plinth are assembled as this comes flat packed, so like the image you can see here on the far right. Cables come in via the opening near the base and up through the plinth. The dirt and rubble that was initially dug out are used then to backfill the plinth, holding it in place, and then the enclosure is simply screwed down to it using the predefined holes. But as I mentioned earlier, should the enclosure need to be removed at any point, it's easy to take the plinth away as well as no wet concrete's been laid. So this is a good solution as opposed to leaving a solid concrete plinth that will either be left in situ or it might need extensive works to dig it up for it to be removed. This can simply be taken away and disposed of rather than leaving it on the site. So we've covered a lot about single skin and double skin, and we've gone through a lot of the features that looking at floor standing enclosures, but what about wall mounted options? What do we have? Now we can see here, we have a stainless steel enclosure, which incorporates a roof canopy, and a GRP enclosure. So I want to discuss the differences between the two. Now the GRP enclosure here obviously offers a great maintenance-free option as the material composition means it's ideal to be used in very harsh environments. It's not going to corrode. It also offers a rain strip, as we saw earlier, to provide the protection that we need. However, some GRP wall-mounted enclosures also offer an encapsulated design. And what that means is it's effectively a double skin, or it's an enclosure within an enclosure. So again, it helps with the UV solar gain that we mentioned earlier. It also offers extra protection due to the design of material from electrical shock. So obviously it's GRP and you've got the double skinned. So again, it helps with the earthing of the panel. On this enclosure, there's the ability to create multiple internal configurations of the internal equipment without damaging it or damaging the integrity of the enclosure due to the mounting domes that's inside. We can simply screw components and accessories into these mounting domes. I'd suggest looking at this if you choose a GRP enclosure with the manufacturer first, what offerings there are for the internal fit out. As we can see on this one, we've got the different types of mounting domes, but not all GRP enclosures are manufactured that way. So like I said, it's something worth considering in terms of future-proofing the enclosure. Is the internal configuration right now? Will it be right at a later date? What are your options for upgrading that cabinet at a later date? So I said, do speak to the manufacturer on that. If we look at the stainless steel option, then in order to make it a more outdoor friendly solution, we'd need to install a rain canopy to protect the seals. However, the enclosure again is still only single skinned. Now we established earlier that at times that's okay, that's acceptable depending on the application. But again, we need to consider that potentially stainless will corrode. It's significantly heavier and it will require a rain canopy to be added and it may not be as cost effective. So when you look at that overall solution, you need to decide whether it is that is the right option for your project based on cost, material, the extra works involved in making it an outdoor solution. So more and more manufacturers are moving towards GRP for outdoor industrial applications, not just enclosures, but things like gantries and walkways. Again, that would have previously been made out of stainless steel, but would have suffered over time just the environment. So they are looking to make these out of GRP, again, because of all the things that we've discussed, the fact that it works better outdoors, it's cost effective and it's lightweight. Now, one last option I'd like to mention is the possibility to retrofit an outdoor solution onto an existing enclosure outdoors. It happens all too often that the wrong enclosures are fitted outdoors, and it will continue to happen, but it might be worth looking at what options are available to protect that existing enclosure rather than having to take it away and completely replace it. So we can see here that an internal enclosure, it's a standard sheet steel enclosure. However, the outer housing is a powder coated aluminium and simply fits around the existing enclosure. This means that the seals are now protected and the enclosure is directly protected from the elements. Whilst it's not necessarily the best solution, there's substantially more protection than was there before. Now the solution above means a lockable front cover again, giving that extra protection for the north rise access. But again, like I said, we're protecting the initial enclosure from the elements to a certain extent. Obviously, heat and humidity will still be exposed to due to the louvers in the outer housing, but it will offer more protection than it previously had. So to summarise what we've talked about when it comes to choosing the right solution for outdoor, while stainless is good, it's not always the best option. We've talked about GRP, we've talked about aluminium, and it is worth considering these as potentially being more outdoor suited materials. IP ratings, again, higher IP rating doesn't always mean outdoor. Remember, IP55 suffices for most outdoor applications. Climate control. It's always good to do a thermal calculation. Don't assume. This will only lead to poor performance, if not failure of the internal equipment. Use the right climate control, whether that be cooling, whether that be heating. Speak to us, we're more than happy to support you with this. And then for me, the design of the enclosure, arguably that's the most important factor. If it's not specifically designed for outdoor, then it will more than likely fail. I can't stress that point enough. If you're looking at an enclosure to use outdoors, speak with the manufacturer, ask what specific outdoor design features or approvals it has, and let them guide you through that process. So what can we do to help? We have a plethora of information on our website on specific outdoor enclosures. We do have very specific outdoor brochures in case that is available. As I said, so we can talk you through different applications that you might have. Generally for outdoor, the fundamentals of the applications are the same. It just might mean that we tailor the enclosure to suit a specific project that you might have. And again, that's what we're here for. The team of product managers are here to support you in anything that you may have, whether it be the enclosures, whether it be power distribution, the internal fit out, or the climate controls. We do have showrooms as well in Yorkshire and Canary Wharf, whereby we can showcase product and discuss some requirements that you have in more detail, so we can do this face to face. Because like I said, I fully appreciate that sometimes it's good to look at products and solutions in the flesh, so this can be arranged. Thank you for your time this morning. I hope at least some of that was useful to you. We have had some questions come in, so I'm going to work through these and I'll get back to you individually on a one-to-one session. Thank you for your time.